guys, now we're on the second lesson this week. Okay, it's the same topic. We're just going to go through another example. Oh, أهلا وسهلا أهلا وسهلا يا أبو حمص. كيف حالك كيف حالك? Very good, very good. How are you? What a surprise. What are you doing here? I come to visit you in South Africa. It's very, very nice here. All the way from Israel. Israel, are you coming? Yes, Israel. Yes. So how are you finding it, Abu? Sorry, guys. This is a good friend of mine from Israel. His name is Abu Hummus. أهلا وسهلا. أهلا يا ولاد يا أولاد. Yes, Abu Hummus, he can speak a bit of English. As you can see, he's got a bit of a different accent, okay? Yes, I have a different accent, so what's the problem? What's the problem? My English is not good enough. No, of course, it's very good. It's very good, Abu Hummus. I just talk to these kids, tell them. Okay, I know you're joking. So, how's it going? How are you finding South Africa? I love it. You love it, isn't it? Yeah, why do you love it? Look, the people are so nice. Everyone is so relaxed. It's not like in Israel. Everyone is always like, I know what you mean. But you know what? One thing is, it's very slow here. Yeah, everything's slow. I mean, look, in Israel, we already have the second wave of this corona. You guys are still with the first wave. Yes, Abu Hummus, sometimes actually going slow is not so bad. You don't want to rush things, I like this slowness. Yeah, it's good. Okay, so I want to tell you also, Tal, ya Habibi, like I saw what you did there on the board, but it doesn't always make sense. I mean, you're testing differentiability, right? Yes, differentiability. So what's the problem? Why are you using the definition? Are you Majnoon? Why Majnoon? Well, it takes so long. It took you like 10 minutes just to show the differentiability. Look, I'll show you how you do it. Listen to me, ya awlad. Don't listen to this Mr. Lisham. Listen to me. Okay. You're going to listen to me. Look, you want to show that this function is differentiable. Okay? You want to show that the derivative from the left of minus 1 is equal to the derivative to the right of minus 1. Is that right? Yes. Okay. So what you're going to do is just find the gradient of the tangent of the line before minus 1 and after minus 1. How you do it? Using the rules that I'm sure Mr. Lisham taught you a few lessons ago. Okay, how do we do it? I'll write for you. Yeah, I'll write for you. Okay. So you want to find out the derivative, okay, at x equal minus 1, okay, from the left. Okay, how would I write it? I want to write it like this. Okay. When x, so we'll find the derivative in the limit where x approaches minus 1 from the negative. So if I find the derivative from the negative, I have to use before minus 1. This one. Yeah. How do I find the derivative of that? Oh, that's not a problem. It's simply 2. Straight away you need to know that. This is the number before the x, right? Okay, I see what you're saying. And then you do the same thing, this time, when you approach minus 1 from the plus. Now, which function are you going to use? Now, this one, yeah. This one. Okay. So, what is the derivative of minus x squared plus 2? It's simply minus 2x. Okay? But I know what x is. What is x? X is minus 1. So I need to substitute 2. Sorry. There was a minus there, yes. Yeah, I did write the minus. Okay, I wrote the minus. What do you want from me? Okay, so it's going to be minus 2 times minus 1, which is also equal to. Well, this is much quicker. It is. You're right. Thank you very much, Abu Hummus. Take care. I'll see you next time. Bye-bye. مع السلامة يا أولاد. مع السلامة. Okay, alright. So he's got a point, I gotta say, okay? You can use the definition, find the derivative according to definition, or you can use the rules that we developed last lesson to find the derivative, okay, when I approaches x equal minus 1 from the left or to the right. Okay, remember how the rules we were doing, okay? It was that sort of thing. So if f of x is ax the power of n, then the derivative of x is going to be max power m minus 1. So the derivative of 2x plus 3 is simply going to be 2. The derivative of minus x squared plus 2 is going to be minus 2x. Okay? And when x equal minus 1, that's going to be equal to as well. So the derivative is the same. Fantastic. Okay, let's move on to the next example. Okay, so in the first example that took us like 2 hours, we looked at the function that was continuous and differentiable. Now we're going to look at slightly different situations. So we've got another function, minus x squared plus 4, x minus 2 absolute value, and the stitch is also at minus 1. But, okay, that's a big but, okay, there's no equal sign here. In other words, the function is actually not defined at x equal minus 1. So we can already say that there's a discontinuity. We don't know if it's jump discontinuity or removable discontinuity. We'll find that out in a minute. But if the function is not defined at x equal minus 1, we know it's not continuous at x minus 1 because we will go back to our little person in a minute. So let's look at what happens to the lift of the stitch. Minus x squared plus 4 is a parabola. It's a sad face. Okay, so I'll put here minus 1. There is a sad face parabola here. Crosses the x-axis. Now in that case, yes, we will have to find out where does it cross it, but let's just not worry about it right now. Let's find out what's the value of y here, because we will need it later on. So I'll just put minus 1 here. It's going to be, watch out for that minus here, because it kind of ambushes it. So minus 1 squared is 1. That was the 1, but then I need to time by minus 1, so it's minus 1. Plus 4 is 3, so this is 3. Okay. Now, x minus 2. X minus 2 in absolute value, this is one of these V shapes. You remember we learned about these V shapes early on. Okay, it's an absolute value function. Okay, there is another, some kind of fishy thing going on here too, right? In 2, okay, so we got that V. I can't remember, we had a name for that point. I can't remember what we call that point. Okay, but it's basically 2 straight lines that meet at x equal 2. Okay, so already we know that there is a discontinuity here. There is a discontinuity. We need to find out if it's, I mean, I just drew it there. I can't really know. I don't know actually know if it touches there. So yeah, before I do that, to find out what's the value at minus 1, I need to put minus 1 here. So if instead of x, I put minus, let's write it down. Okay. So minus 1 minus 2 is going to be the absolute value of minus 3, which is 3. So even if I work according to this side of the function, okay, over larger than minus 1, I will still get the value of 3. So these two lines do meet, okay? That means I can calculate the limit, but I'm not going to, well, I kind of did it, okay? If I move from the left, the value of the function will be 3. If I move from the right, the value of the function will also be 3. So it's a removable discontinuity. I could just add here, if x equal minus 1, the answer is 3. Or, I don't even need to do that. I can just add an equal to one of these, either that or that. Okay? And then suddenly, it will be continuous. Okay? But as it stands right now, there is a removable discontinuity. Okay? Everywhere else, obviously, it's continuous. Okay? We've got the little feet can walk everywhere except for that little white hole there. Okay? Now, is it differentiable? Okay. Just going to pause here for a second. Okay. Now, looking at differentiability, there's 2 suspicious points where I might ask myself it might not be differentiable. Everywhere else, here is not a problem, here is not a problem, here is not a problem. We've got 2 points, right? This point, I can straight away say it's not differentiable, because if you remember, the first condition for differentiability is that continuous. Okay? Doesn't matter, it doesn't matter if it's removable discontinuity or jump discontinuity. If it's discontinuous, then it cannot be differentiable. Okay? Right? So this is not differentiable. Okay? Not differentiable. Okay? So the other points that I'm a bit suspicious is here. Now this point is continuous. If you remember, okay, differentiability is not just continuous function. function. Differentiable function is not just a continuous function. It's not just the little feet managing to walk from one place without any state. Our little feet are also sensitive in sudden changes of a gradient. Okay? The gradient can change, there's no problem. But it needs to change continuously, gradually, not suddenly. Now here, that V shape, you can see that there is a sudden change of gradient. So that's very suspicious. Okay? And that's probably going to be non-differentiable. Let's prove that. Okay? So to find out if it's differentiable or not, I need to find out the derivative, okay, when x approaches 2 from the left, and the derivative of the function when it approaches 2 from the right. Okay? So to find out the derivative, I need to know what the function is. If I move from the left, okay, that means x is smaller than, it's not x is smaller than minus 1, it's x smaller than 2, right? Because I'm approaching 2 from the left. So if x is smaller than 2, okay, x minus 2 will be a negative number. So x smaller than 2 could be like 1.9. It's not negative, 1.9. Now 1.9 minus 2 is minus 0.1. In other words, a negative number. Now if I know I have a negative number inside this absolute value, what that absolute value does, it multiplies that negative number by minus 1 to turn it into positive. So the value of the function will be minus x minus 2. Okay? Okay? That's what the value of the function. And that I need to do derivative. How am I going to do that right in a nice way? Okay? And they just did it straight away. I want to make it more clear for you. So what I'm going to do, find the derivative of this, or now I'll go to the other notation. So we're going to find the derivative of this function. This is the function. When I approach 2 from the left, the function is minus x minus 2, or 2 minus x. Okay? So I'm going to find the derivative, okay, in the limit. X approaches 2 from the left. I'm going to find the derivative of 2 minus x. Okay? All I did, I just multiplied everything by minus 1. Now, what is the derivative of 2 minus x? Okay, according to these rules that we learned, okay, I'm going to write down limit x approaches 2 minus. It's simply minus 1. Okay, it's the minus negative number, it's minus 1. That's it. So I don't even need to substitute 2 because there is no x to substitute. So the answer is minus 1. And you can see that the derivative before 2 is indeed, it must be a negative number because it's going down. Now let's do the same thing. Find the derivative to the right of 2. Okay? So we're going to find the limit when x approaches 2 plus, and we'll find the derivative. What is the function now? What is the function now? If x is larger than 2, then x minus 2, x could be, let's say, 2.1. 2.1 minus 2 is 0.1. It's a positive number, so I might as well get rid of the absolute values, because the absolute value of a positive number is simply the same. It's the absolute number. So I'm just going to write x minus 2. Now, what is the derivative of x minus 2? It's simply minus 2. Okay? And because I got, sorry, it's not minus 2. Crazy. So thank goodness Albert almost wasn't here. He would be very cross with me. Okay? What is the derivative of the function x minus 2? It's simply that constant in front of the x. It's plus 1. Plus 1. Okay? So I'm getting plus 1, okay? And I got rid of the limit because I don't have any more x's, so I don't need that limit if x approaches 2, because it's just plus 1. So, what did I get here? If I approach 2 from the right, okay, the gradient of the tangent to that curve is plus 1. Okay? If I go from the left, it's minus 1. Okay, so I've got limits for the right and the left. I've got gradient from the right and the left. But they're not equal. Okay? I have a sudden change in the gradient. Okay? And this is really, really important point. This little point here, what I'm going to say now, it's very important that you understand that. Okay? I'm going to bring my little cursor here. Okay? The function at 2 is continuous. Okay? There's no jumps there. That little person, tiny little person with the tiny little feet, walk from here to there, no problem. He can cross 2. but it's not differentiable, okay? Because if I take his, I don't know, his cousin, who's even more tiny person with tiny feet, that little blue person, he's so sensitive that even when it's continuous, his cousin, the continuous person, can walk through it, he's so sensitive to sudden change gradient that he can't go. If he feels like there's a sudden change in the gradient, you can see it goes from -1 to +1, even if it's continuous, the green man can go, the blue person can't go. He can't cross. So that function is continuous at x equal 2, but it's not differentiable. Okay, let me just check that I've covered everything, and I'll let you go. Guys, go. Cool, so that's it, guys. Please do exercise 5.4, and I will give you also the rest of this week and part of next week also to do exercise 5.5. Okay, I'll have a look at it later, but it doesn't look like there's anything new there. It's just putting a whole bunch of ideas together. Okay, it's not easy stuff. Give it time. I will give you time, and we will do a test. It might be the following week, the next week, or the week after that. But we will do one more test before the end of this term. It's not going to be a long test. It's probably going to be just 30 minutes, and I'll give you some more information about it on the WhatsApp group. Have a lovely day. Enjoy the rest of the week.